So we're going to be looking at some applications of trigonometry. And one application is a vector. Those of you that are taking physics, this is just a brief introduction so you have an idea when you get into the science class. So a vector show a shift. We're going to do it both visually, geometrically, and algebraically. And what they show is how far this object is going to move and in which direction. So there's some notation. In writing it, you'll just do a V with a little half arrow on top. But if you're looking at a textbook, they'll have a V that's really thick, and they're using V for vector. That's a common notation, as is U. But they'll make it really thick and bold. Okay, so for our purposes, we're going to write vector notation with this half V. We're going to be drawing vector diagrams. A vector diagram is simply an arrow. So we have a start and we have a stop. And so we call this end of it right here the tip of it, and this end right here the tail. And so we can draw them all sorts of different directions and lengths. So what we're going to do is try to find that direction and length, and the magnitude is that length. The magnitude is going to tell us the distance. It is the length of the vector. So if you go back to this initial drawing, you can tell that this has a longer length, so it must be more of a force or a velocity, depending on what you're measuring. So in geometry, if we're looking at the picture, like we just said, it's the length of the vector, how long it is. In algebra, which we're going to be doing mostly, is I want to find it, and I want to give it a number. And so when I have a vector, and I'll just happen to draw one in, it doesn't really matter, in this direction. There's my tail and there's my tip. What I can do with something slanted like this, no matter in which direction, I can make a right triangle out of it. And I'm looking for the length of the vector. So in this right triangle, it will always be the hypotenuse. So I could call this x because it's in the x direction, horizontal. I'll call this y. It's in the vertical direction. I'll be looking for the magnitude. And so to write down magnitude, we won't write the word magnitude or length. We have a symbol. So the symbol for magnitude is this thing. It's a double line, the vector, and then the double line. So that's called magnitude of the vector. It's just asking you how long it is. It's looking for the hypotenuse. And so if we go ahead and apply our right triangle trig, we can say the magnitude of vector v is equal to x squared plus y squared, but then I'm going to need to take a square root. And that would give me the magnitude, or how long it is. We're also going to be looking at direction of the vector, so I'm going to draw another vector here. And what I'm looking for is the direction that it's headed. So I'm going to go ahead and again make a right triangle, and I'm looking for this direction called theta. Theta is the direction off of the x-axis for our purposes. In physics, you'll be measuring off of a thing called a bearing off of due north. Don't worry about that. It's the same idea. We're just going to measure off of the x-axis. And so, if I look at this, I know that this distance was x and this distance was y. It was formed by the right triangle off of this vector. And so if I use my right triangle trig, because that's what I've just formed here, the tangent of theta is the y over x. And if I want to find theta, I need to undo the word tangent, and that's by taking the inverse, and that will give you theta. And that inverse is in the calculator. So again, we're measuring our direction off of the x-axis. So let's go ahead and take a look. Here are two vectors. Let's look at the first one. I want to find the magnitude of this vector. So in order to find the magnitude, I'm asking for the magnitude of vector v. That's how you'll see it asked for. And if I go ahead and make a right triangle out of this, I can see that my magnitude is the hypotenuse. And in order to find the hypotenuse, I need to know how long the horizontal direction is and how tall the vertical direction is. And so if I look at my scale, that's a 2 and a 4. So my magnitude is going to be 4 squared plus 2 squared, and then I'm going to take the square root. I also want to know this angle. And to find that angle, the tangent of theta is 2 over 4. Recall I want theta. So it's the tangent inverse of 2 over 4. So if I have a calculator, I want to make sure I'm in the correct notation, or units of measure, I should say. I want to be in degrees for this purpose, and I believe that that's what your homework asks you to be in as well. So I'm going to find the tangent inverse of 2, 4. So tangent inverse is this button here of 2 divided by 4. And this is going to give me about, I'm just going to round it to 27. So my direction, okay, is 27 degrees, and I'm measuring off of the x-axis. So theta is 27 degrees. We can have vectors pretty much land in any quadrant. And so if I take a look at this vector, it looks like it is 3 in length and 1 in height, and it is going down. So again, if I'm looking for the magnitude of the vector, it's equal to the square root of 3 squared plus 1 squared, which would be 9 plus 1. It's the square root of 10. Guess I could have done that over here. This would have been the square root of 20. So back to this problem, the vector length is the square root of 10. It's called the magnitude. Notice the notation. I want to know this angle. So I see that the tangent of theta, tangent is TOA opposite over adjacent. Notice I didn't put the negatives on there. I'm going to deal with that here in just a minute. So tangent, I'm going to undo it in my calculator. Tangent inverse of 1 divided by 3 is going to give me the angle, which is about 18 degrees. So this angle in here is 18, but that is not my direction. So that gives me 18 degrees. This is my direction. So it's kind of that idea that we did with reference angles. So it's going to be 180 degrees plus that 18. So my direction is 198 degrees. So if I had a protractor, I could go 198 degrees, and then I would make my vector a length of the square root of 10, which is a little bit more than 3. So that is magnitude and direction. Those are the two things that describe a vector. In this class, we're just going to measure the direction off the x-axis. Typically in physics, it's measured off the y, and that is for the reason of being due north.